example. Let's say we have a function y is equal to 5 minus 2 to the power of 3 minus x. Now let's see how to draw the graph for this one. First, if you have a graph, if you have an exponential function, you have to always equate the function that is associated with x to be 0 and 1. So here we have this one 3 minus x, that is equal to 0, and also 3 minus x, that is equal to 1. These are the point of interest. And from this one we also know the horizontal asymptote, that is whatever the constant you're going to have with the exponential function. So here is 5, so the horizontal asymptote is 5. Horizontal asymptote y is equal to 5. Now if you solve this this one, 3 minus x is equal to 0, 3 minus x is equal to 1. These are the point of interest. To solve this one, you can move the x to the other side. That's going to give us x is equal to 3. And here if you move x and 1 to the other side, if you switch x and y, this is going to x is equal to 3 minus 1, that is equal to 2. So these are the 2 points of interest we are having. Now let's go ahead and create xy table. In the xy table we put this point of interest like x is 2 and then x is 3. Now we have to find out the y value for these 2 points. Now to find the y value, we plug it in this given function, that is y is equal to 5 minus 2 power 3 minus x. Now let's go ahead and plug 2 first. So y is equal to 5 minus 2 power 3 minus 2. That's going to give us 5 minus 2 power 1. That is equal to 5 minus 2. That is equal to 3. So the first y value is 3. Now let's go ahead and plug 3 for the x value. So this is going to be y is equal to 5 minus 2 power 3 minus 3. That's going to give us 5 minus 2 power 0. 2 power 0 is 1. So this is going to be 5 minus 1. That is equal to 4. So the answer for this one is 4. The y value is 4. Now we have the two two points of interest, and also we have the horizontal asymptote. Now we can go ahead and plug it in the graph and draw our graph. Now I'm going to remove all these things. Okay, let's draw our graph. And first always start with the asymptote. Here our horizontal asymptote is x is equal to, y is equal to 5. Let's plug some y values. Let's say this is 1, 2, 3, 4, 5, and at 5 we are going to have a horizontal line like this. That's our horizontal asymptote. And then let's go ahead and plug the values we found. The first one is when x is equal to 2, y is 3. So let's put some x values. 1, 2, let's say this is 2, and then at 2, y is equal to 3. Okay, so it's going to be right here. And when x is equal to 3, y is 4. X is equal to 3, y is 4. Okay, and since we are having power negative x, that's why you can see the exponential graph goes this way, like this, and it's going to keep on going, and it's going to cross this line as well. So the domain is going to be, domain is what are the possible x value. This one, as you expand, it's going to cross this one and keep on going forever. So the domain is going to be negative infinity, and then in the positive, where it's starting from positive infinity. What's the highest value you can have? You cannot say starting. What's the highest value it can have is positive infinity, because with this asymptote it's going to going forever. So that's positive infinity. What is the range here? Range is what is the lowest value of y value. Here the lowest value of y value it can have is negative infinity. And what's the highest value of y value? That is 5, because 5 is our asymptote and it's at 5 and it never touches 5, so this is gonna be a circle parenthesis like this. Okay, now we have the domain and range, and we found out our graph. Now let's look at exponential graphs, the possibility of having different shapes and stuff, and we can actually analyze this and get a better idea of it. Now for that I'm going to erase everything. Now let's look at the pattern of exponential functions. Let's look at the first one. So first one, let's say we have y y is equal to 2 power x. The graph look like this. It opens up in the quadrant 1, and let's say we have a function that is y is equal to 2 power negative x. Now it opens in the quadrant 2, so it's actually flip of this one. You can see as the x become negative, it flips in the y-axis. And here if you have y is equal to negative 2 power x, now this function flips in the x-axis, so the graph is going to look like this. It's going to go like this and go down. And let's say we have a function that is y is equal to negative 2 minus x power minus x. The graph is gonna flip down, flip in the x-axis, so it's gonna look like this. Now if you notice, there's a pattern here. The first one is going up in the quadrant 1, the second one is going up in the quadrant 2, and the third one is going down in the quadrant 4, and the fourth one is going down in the quadrant 3. Now how can we relate this one? Here what we have to do is we have to think this one like x value, and this one is y value. So when the x is positive, you can see it's going toward the positive x-axis, like it's going to the right side, and when the y is positive, it's going up. And here for the second one, you can see when the x is negative, it's going to the left side, and y is positive, so it's going up. And for the third one, you can see when the y is negative, it's going down, and x is positive, so it's going to the right. And then here in the last one, you can see when the y is negative, is going down, and then when x is negative, it's going to the left. So if the x is positive, it's going to go to the right, and if the y is positive, it's going to go to the up side. If the x is negative, it's going to go to the left side, and if the y is negative, it's going to go down. So you can make an analogy like that when you draw the graph. And that's it for this video guys. Thanks for watching. So see you guys on